All right. Well, let's check another typical exam question on our probability. We are going to consider, that is question number 8. Given 8.1, there is an information that we are given in a certain class of 42 boys. We are given, this is a presentation of our class. 27 play hockey, which is H. 32 play soccer, which is S. And 7 do not play hockey or soccer. And a unknown number X plays both hockey and soccer. So they gave us the Venn diagram presented. In normal cases, they are actually going to ask you to present that. Remember, guys, if you're given those ones who take both, you represent them on the intersection. From the hockey that we are given, which are 27, you subtract X. The S that you're given for soccer, you subtract X. And the 7 who do not play any of these two are the ones that you are going to present outside. So this is how you're going to present. I talked about this from the previous exam questions that we had before. And this being our sample space, having a total of 42 boys, all the number of boys that we have there, 42. So the question was on 8.11 to calculate the value of X. So we can take advantage of the whole of this information because we do understand that each and every section on our diagram must add up to 42. The 27 minus X, so that's our 8.11. The 27 minus X, so we have got the 27 minus X plus the X plus the 32 minus X plus the 7, which is outside, must give us a total of 42. That's forming an equation which we can solve for X. As we can see, the minus X plus X cancels. You remain with minus X. Add the numbers 27 plus 32 plus a 7, that was going to be 66. That is equal to 42. So minus X is equal to, take the 66, it's going to be a negative since it was a positive here. So that's 42 minus 66, which is negative 24. So to find X, simply divide by a negative in that case. So that was going to be a positive. So that's our X in this case is 24. Wherever we see X, there is a 24 there. So meaning to say you can even substitute wherever there's X 24, 27 minus 24, which is 332 minus, you can even substitute whatever part that you are given. Then on 8.12, as a continuation from this same diagram, you're saying if a boy from the class is chosen at random, calculate the probability that he, A, does not play hockey or soccer. This is the probability of the section of hockey or soccer complement, not part of hockey or soccer, meaning to say we're talking of those that are outside of these two sets. Outside, meaning to say we're talking of the 7 that we are given. These ones, they do not play these two hockey or soccer. How many are they? There are 7 out of the number of boys that we have, which is 42 in the class. Remember, there are 42. Like I said, you can write it as a decimal, as a percentage. It's up to you. B, plays only soccer. Only soccer. Which part is of soccer only? The whole of this set, it was soccer. But because there are these ones who are playing both, you'll see that those who play soccer only will be this section of the 32 minus X. But remember, as we calculated our X, in that case, our X was 24. So meaning to say that is 32 minus 24, which is going to give us 8. So those who plays soccer only, it's only 8 that we have there. So these ones, they are 8 out of the total number of 42. This can reduce to 4 over 21. You can also write it as a decimal 0.19, depending with what you're given, but they were not given any instruction. You can also write it as a percentage. It's up to you. 8.2, we are given A bag contains 3 blue balls. That is what we have. 3, they are blue. X yellow balls. 8.21. Write down the total number of balls in the bag. How many balls do we have? It's an expression because we do not have the exact number of the yellow. They are given in terms of X. So we are going to have an expression. They are supposed to write it like this. Write down an expression, because we do not have like the numerical value. So they are supposed to ask it this way so that you also understand what are they asking there. So it's an expression for the total number that you're given, which is simply add. So it was simply going to be 3 plus x. You simply add these two. These ones, they are 3. These ones, they are x. If these ones were 4, it was going to be 3 plus 4. If these ones were 7, 3 plus 7. So this is the total. You just have to add. So if a ball is drawn from the bag, write down the probability that it is blue. How many are blue? That is the question. How many are blue? The probability of being blue, how many are they? They are 3, which are blue. Out of the total, what is your total? It is 3 plus x. So again, this is an expression. Write down the expression for the probability. It's supposed to be the expression or an expression for the probability of this. All right. Anyways, that is what you're supposed to have in terms of x. 8.3. 8.31, complete the following statement. If A and B are 2 mutually exclusive events, then the probability of A and B is what? That's a 0. Mutually exclusive events, they do not intersect. There is nothing on the intersection. 8.32, given that A and B are mutually exclusive events, just like what we had before, where we say the probability of A and B is equal to 0. But now they are saying the probability that A occurs is 0.55. The probability that B does not occur, B does not occur. Meaning to say the probability of B complement not in B, it's 0.7. That is what they are telling you there. Does not occur. So the question was calculate the probability of what is in A or B. Okay, let's finish this one. This statement, this is from the complement of sets. From our complement, I said, if it is the probability of anything that you are given to its complement, you must get a 1. Guys, whether it's B, whether it's... So meaning to say, if I have to use this, it means the probability of what is in B plus what is not in B must give us a 1. It can be of whatever combination. I explained that it can be like this, the probability of A or B plus what is not in A or B. As long it is this and its complement, you must get a 1. So using this, guys, we can calculate the probability of what is in B first. So the probability of what is in B is going to be 1 minus the probability of what is not in B, which is 1 minus what is not in B, which is 0.7. That was going to give us 0.3. So from what is not in B, we can determine the probability of what is in B. We can have the probability of what is in B from what is not in B. You simply subtract from 1, which is 0.3. That is what it means. But this is not our question. We just need to have that, because we cannot work with B complement where we need B. We need what is in B. So the question was, We need the probability of A or B. Remember, we are told that these two events that we are given in this case, they are mutually exclusive events, where we do understand that A and B must be equal to 0, just like what we mentioned here. If two events are mutually exclusive, the probability of A and B is a 0. So meaning to say that statement is not going to be missed. So in actual sense, we're supposed to have the probability of A plus the probability of B minus the probability of A and B. This is what we're supposed to have, guys. Yes, if you know this, it's fine. But know that there is nothing here, guys. It's a 0, this one. So instead, for mutually exclusive events, we'll end up saying the probability of what is in A or B is simply equal to the probability of what is in A plus of what is in B. Just like that. So we have what is in A, 0.55, plus what is in B, which is 0.3, the one that we calculated. If you wanted to use that formula of a minus what A and B, you're going to use it minus, but what is in A and B for mutually exclusive events? It's a 0. So it means that there's nothing. So if you understand that way, guys, it's up to you. You can write it that way. Still, you're going to have the same answer, which is 0.85. So that is the probability of A or B that we are being asked there. It was supposed to be considered. What are the events given? How are the events presented? They are mutually exclusive events. So by understanding that alone can help us to answer this question. So let's revise as much questions as we can.